So we're talking about polynomial functions, so it's important to think, first thing, which graphs represent polynomial functions. Well, this graph here does. That's a polynomial. This one is an absolute value function, so that does not. So f does. I guess I should write yes. Yes. No. And then we have this one is also yes. And this is not, so this is no. Why? Because there is a spot here where it does not connect. So it's not continuous. How to find the x-intercepts of polynomial functions by factoring. Set f of x equal to 0. If the polynomial function is not given in factored form, factor out any common monomial factors. Then factor any factorable binomials or trinomials and set each factor equal to 0 and solve for the x-intercepts. Okay. And so we're going to find the x-intercepts here. First thing I'll do is I'll factor out. It looks like 2x squared, or sorry, x squared is a factor of everything. So x squared times what's left? X to the 4th minus 3x squared plus 2. So this follows that substitution. If I were to say u equals x squared, this can be u squared times u. Sorry, it's u, not u squared. U times u squared minus 3u plus 2. Because x, if this term is u squared, that's u squared is x squared squared, x to the 4th, so on. And we have u times u minus 2 times u minus 1. So u, we're going to set each of these this equal to 0. So u equals 0 means x squared is 0, which means x is 0. U minus 2 equals 0 means x squared minus 2 is 0. So x squared equals 2, or x equals plus or minus the square root of 2. U minus 1 equals 0 means x squared minus 1 is 0, or x squared equals 1, or x equals plus or minus 1. So our zeros, our x-intercepts, I should say, are going to be at 0, 0. We're going to see at square root of 2, 0, negative square root of 2, 0, and then we have 1, 0, and negative 1, 0. Okay. One thing I want to point out is that it's the 6th power. We have 5 x-intercepts because this first one's a double one. Or double 0, because it was x squared equals 0. Okay, next one. Find the x-intercepts. So we have x cubed minus 5x squared minus x plus 5. So I'm going to take x cubed minus 5x squared minus x plus 5 and set that equal to 0. Then you can rearrange this if you want. The order of things, you can't rearrange the values like I just miswrote. But x cubed minus 5x squared, I'm going to group those together. Minus x minus 5 equals 0. Now I could have rearranged this and put the 5x squared and then the 5 together. But I just left it like this, obviously. Out of the first pair, I can pull an x squared out, and we have an x minus 5 left. Out of the second pair, nothing in common, so I'll put a 1 out here, and we have x minus 5. So we have a repeated factor of x minus, change the color, x minus 5, and then, oh man, I'm just not keeping track of my colors. Then we have an x squared minus 1, so x squared minus 1 equals 0. So, and we can factor the x squared minus 1 because that's a difference of squares. So x minus 5 times x minus 1 times x plus 1. So x minus 5 is 0, means x equals 5. X minus 1 equals 0 means x equals 1. X plus 1 equals 0 means x equals negative 1. So we have 5, 0. We have 1, 0. And we have negative 1, 0. Notice it was a cubed, and there's 3 of them. Okay, that's fun. So we got 2 more of these. Oh, okay, that one we could use a graph. Okay, find the y and x-intercepts. These are the x-intercepts. Now we do y and x-intercepts. Well, our y-intercept is just going to be at x equals 0. So we look at g of 0 is 0 minus 2 squared times 2 times 0 plus 3. So it's negative 2 squared times 3. That's going to be 12. So at 0, 12 is the y-intercept. Now we can take this x minus 2 squared times 2x plus 3, set that equal to 0. So we have x minus 2 equals 0 means x equals 2. 2x plus 3 equals 0 means 2x equals negative 3, or x equals negative 3 halves. I should have noted this is x-intercept. So the x-intercepts are going to be at 2, 0, and negative 3 halves, 0. So I want to point out here is, yes, we have an x here that's squared, and then there's another x, so it would make an x cubed. In fact, 2x cubed would be the leading term. But we only have 2 x-intercepts because this is a double root. I know that they didn't ask us to find that. Double 0. Okay, the next one, we get to find these x-intercepts by graphing it. So we get to do a Desmos. How fun. Hang on. Okay, so we have h of x equals x cubed plus 4x squared plus x minus 6. Okay. And here are the zeros. I did not see this coming. So that one, negative 3, 0. Here we have negative 2, 0. And here we have 1, 0. So we have negative 3, 0. I'm making a note for myself. Negative 2, 0, and 1, 0. That's kind of nice. So we have, from the graph, it looks something like this. And it was we had a negative 3, negative 2, and a positive 1. So one like that. So negative 3, 0, negative 2, 0, and 1, 0. Okay, that's the easy way to do it, is graphing it. Okay, this one's gone a little long, so we will get back to this in the next video, identifying zeros and their multiplicity.